If x with an exponent of a squared over x with an exponent of b squared equals x to the 16th, and x is more than 1, and a plus b equals 2, what is the value of a plus b? The problem asks us to solve for a minus b, and it offers that x is more than 1, which we need to keep in the back of our mind, and that a plus b equals 2. It seems like this information would come handy, but for now, let's try to size up the problem. We're given x in the numerator and x in the denominator, and it has the exponent in the form of unknowns a squared and b squared. And it equals to x with an explicit exponent of 16. If you remember how to divide two numbers with exponents with the same base, then you can save some time. But let's assume you kind of forgot how it works. What you can do is you can randomly come up with your own fraction in a much more comprehensible format. So let's take x in the third over x in the second. We can unwrap it and we get x multiplied by itself 3 times in the numerator and twice in the denominator. And if we cancel it out, we know that we get x in the first power. Looking at the original fraction, we can probably notice that what happened is that in the exponent, we subtracted the 1 in the denominator 2 from the 1 in the numerator 3. So this will kind of remind us how this works. Applying this insight to x in the power of a squared over x in the power b squared equals x in the power of 16, we can see that a squared, the exponent in the numerator, minus b squared, the exponent in the denominator, should equal 16. To connect the dots, look at the example that we created and see the similarities with the one that we're asked to solve, and you'll see how we got here. Let's proceed. So if a squared minus b squared equals 16, then we might be able to recognize one of the 3 special cases. And you can watch a video on this, but one of the 3 special cases of multiplying 2 binomials does result in exactly this, a squared minus b squared situation. There was a reason we called these combinations 3 special cases, and this is a great example of how it might come up during the test. So if we factor a squared minus b squared, we get a plus b binomial times a minus b, and that should equal to 16. We were provided that a plus b equals 2 in the problem question. So now we can replace a plus b with 2, and what we get is 2 times a minus b equals 16. Here we use our knowledge of manipulation, and we want to isolate a minus b. To do that, we need to reverse the operation of multiplying by 2, and we divide by 2 both sides of the equation, and as a result, a minus b equals 8. 8 is the answer choice A, and it is the correct answer. Now let's say you did not recognize this one of the 3 special cases of multiplying binomials and weren't able to factor it. What does that mean? Well, you can do it your own way, and let's consider one of them. By the time we realize that a squared minus b squared equals 16, we will have 2 equations that we can work off each other. In the question, we were offered that a plus b equals 2. So if we want, we can isolate a, and as a result, we'd subtract b from each side and get that a equals 2 minus b. Now with this information, we can replace a in the other equation with 2 minus b and proceed the calculations. What we get is 2 minus b squared minus b squared equals 16. Now, again, if you have the knowledge of the three special cases, you'd be able to unwrap it very quickly and get 4 minus 4b plus b squared to replace 2 minus b squared. Otherwise, you can just factor it into 2 minus b times 2 minus b, and you would get the same input. After we unwrap it, it's pretty obvious that we can cancel out plus b squared and minus b squared. And what we get is 4 minus 4b equals 16. So let's use our manipulation knowledge. Since we're interested in b, let's move 4 to the other side. And since it's added to the minus 4b, let's subtract it. What we get is minus 4b equals 12. And finally, to find b, we need to reverse the multiplication by minus 4. So we'll divide both sides by minus 4. And we get to our final point, b equals minus 3. Since a equals 2 minus b, and now we know that b equals to minus 3, so we can plug it in, we get the answer 5. Our problem asks us, what is a minus b? Since our a is 5 and our b is minus 3, what we need to solve for is 5 minus 3, and that is 8. Answer choice A. This video demonstrates that we can solve questions in different ways, whichever is more convenient for us, and sometimes we can overcome lack of recognition of certain patterns or knowledge of certain concepts. And if we have enough confidence to set it up and simplify, we should be able to solve most of the problems on the test.